Look at these four objects. At the extremes, we have a 1 centimeter marble sitting next to a 24 centimeter basketball. So here's the question. Exactly how many of these 1 centimeter marbles could you pack inside that basketball? Most people will guess somewhere in the neighborhood of a few hundred. Our eyes are naturally trained to measure straight lines, so when we look at the basketball, it simply registers as 24 times larger. But that instinct reveals a structural blind spot in how we perceive the physical world. Our eyes judge size in one-dimensional lengths, while physical space actually operates in three-dimensional volumes. The true mathematical capacity of a standard basketball is actually the equivalent volume of over 13,000 marbles. Look at this diagram. You can see how a single straight line extending 24 times its original length looks incredibly thin compared to a sphere ballooning outward in all directions. Human intuition simply fails to map how rapidly space multiplies. To accurately gauge the physical world, we have to bypass our eyes and rely on a strict mathematical rule. This diagram shows a single three-dimensional cube. We will assign it a length, a width, and a height of exactly 1 unit. Now, watch what happens to the internal space if we increase the linear length of its sides by a factor of 5. The length was multiplied by 5, but the total volume was multiplied by 5 cubed. That creates exactly 125 interior blocks. This exact same geometric structure applies to spheres. The volume of a sphere is directly proportional to its diameter cubed. This means you do not need to calculate the precise volume formula for every object you encounter. To compare the space inside any two balls, you just find the ratio of their diameters and cube that number. This diagram maps out our earlier objects. The ping-pong ball has a diameter of 4 centimeters. By cubing that measurement, we find it holds mathematically 64 marble volumes. Stepping up to the tennis ball, its diameter is 6.7 centimeters. 6.7 cubed yields roughly 300 marble volumes. And finally, applying this formula to the 24 centimeter basketball proves the math. 24 cubed equals exactly 13,824. There is, however, a strict boundary between raw mathematical volume and actually packing physical objects together. Because rigid spheres do not stack perfectly, they leave empty gaps between them. Therefore, the actual number of hard glass marbles you could dump into the physical shell of a basketball is lower than 13,000. But while physical geometry limits how tightly objects pack together, it is the cubic ratio that determines the total amount of three-dimensional space inside. Take a look at this footage of the Earth and the Moon, sitting silently in the vast darkness of space. This diagram maps their cross-sections. If we compare their linear width, the Earth's diameter is roughly 3.67 times larger than the Moon's. When we apply the rule of cubes to these planetary bodies, 3.67 cubed equals roughly 49.4. That translates to nearly 50 small moons fitting inside the Earth's boundary. This shows how easily our visual senses misjudge scale. A planet that appears only slightly wider through a telescope lens actually contains the physical capacity of 50 moons. Whenever we move from observing a single line of length to contemplating a full volume, we cross a threshold from standard scaling into cubic multiplication. The next time you compare two objects in the real world, remember that being just a little wider means the volume has grown by the cube of that difference.